Hello, and welcome to another Otsujin session. How about that? How about that? But you didn't expect that shit to happen. Hello everyone. Hello Egaduk. Hello Thea for Mike 404. Hello Surimun. Hello, hello. How are you guys doing? So today we continue to develop our text editor that we started to develop like 5 or 4 days ago. I'm not really sure. You can find the source code of this text editor in the description and also in the chat. And on the previous episode, we actually started to rewrite our renderer from pure SDL to OpenGL. So, and today we're going to simply continue doing so. But before we actually go into continue implementation of OpenGL, I think we should finally choose the name. So for quite some time, we've been trying to come up with a name for this text editor. And people were suggesting different ideas and stuff like that. But one idea actually, you know, like I liked really one idea. So after a certain pull request, we decided on an idea that the text editor should be extremely dramatic, right? So we're not just want to make like yet another text editor. We want to actually make a dramatic text editor. So this is how it looks like right now, right? So when you start typing, you have a camera that actually pans, and in the future we're going to add zooming and stuff like that. And this is what experience of typing actually feels like. And we want to focus on this kind of experience in the text editor. So this is more of like a dramatic text editor from now on. So, and to accommodate this idea, I'm not really sure if I'm using words correctly, but one of the idea that was suggested is to call the text editor DEAD, which stands for dramatics editor, right? Dramatic editor. And on top of that, it not only stands for dramatic editor, and I don't expect anyone to actually seriously use this text editor, so that's why it's going to be dead. So I think it's a pretty good name. And the first thing we're going to do today, we're going to actually rename everything. We're going to rename the repo. We're going to rename everything in the source code. So from now on, it's a dead editor, dramatic editor. So that's basically what it is. So yeah, that's pretty poke. Isn't that poke, fellow kids? I think it's pretty fucking poke. I think somebody also submitted a pull request that actually added support for the mouse. Let me actually see that. So I'm gonna check out the master. And fetch the latest shite. Alright, so, and I'm gonna merge origin master. OpenGL renderer. There we go. So if I rebuild the entire thing, so it's gonna take some time, of course. And now, if you take a look at this text editor, right? So you can click on particular cells and particular places, and it automatically puts the cursor in there, and actually the camera starts moving there. Alright, so this is basically what was submitted in like off-screen, I suppose. I had to merge it off-screen. Alright, so let's go ahead and rename everything. So the first thing I'm going to rename, I'm going to actually rename this thing the entire repo itself, right? So, and within the repo, maybe we need to first find, yeah, let's do that in a build. So this one is going to be build sh. CE, so this is going to be dead. I think we also need to do something like that in the where is the name? Does it even set the name anywhere? How do we set the name? So it looks like it doesn't even try to set the name of the executable on Windows, probably because FET. Okay, thank you so much. Oh yeah, thank you so much, Simon. FEDED. So, all right. So, and do I need to do anything else in here? I think I'm also gonna update the dramatic editor So dramatic editor, TE, this is going to be dead, and another TE, this is going to be dead, I suppose. I mean, maybe also .exe because it's Windows. And I'm going to create a separate branch and make a pull request and stuff like that. TE dead. So TE dead. And let's push that right into the repo. And also, I'm going to rename the repo itself. Right. Is it gonna ask for a password to rename the thing? Hopefully. Oh, it didn't even ask for a password. Nice. Because it's not particularly destructive change, I suppose. So the cool thing about GitHub is that it will still redirect to a new repo if I try to access the old name. So I really like that feature. So if I try to go here, it automatically redirects to dead. And also maybe it makes sense to update the settings in here. Dramatic editor. There we go. Topics, text, text editor, OpenGL, shaders, SDL2, I suppose. It's a pretty good topic. I guess that's it. So I don't think we need that many topics. All right. So, and in this pull request, we're waiting for all of these things to build. And yep. Hello, apparently potatoes. Hello, Zolder Surf Twitch. Relaxilin. Hello, John Punthong. Hello, welcome everyone. Really glad to see you all today. So yeah, I wonder how much time it will take to... Oh, it's probably gonna be also, yeah, a little bit painful because... Well, no, not really. So I don't think we directly refer to TE. To be fair, I might as well rename build TE to build dead. So build dead. Dead. Anything else? Okay. So update CI YAML. Okay, we'll have to wait a little bit more now. So is something wrong with GitHub today? I'm not sure. So if I take a look at the status, GitHub status, is everything okay? Because it's kind of... Everything's okay. The website slowly becomes more and more buggy, more and more laggy, and status shows everything okay. Welcome to the modern computers. So I suppose while we're waiting, I want to make a small break and just, like, you know, refill my cup of water. It's not going to be very long. It's just like a couple of seconds. Just go to the kitchen and back. All right. So apparently CI is completely broken. I don't know what's going on. GitHub tells me that GitHub status is okay. So I guess we're going to just merge the pull request and move on. Theantonio, thank you so much for 5 months of tier 1 subscription. Thank you. All right. Okay, so let's actually fetch the latest changes. And now our text editor officially is called dead. So it's a dead text editor. Cheers. All right. So did I fetch the latest stuff already? All right. So let's remove this thing. So, as already mentioned, on the previous stream, we started developing the... We started to rewrite our current renderer from SDL to OpenGL. Alright, so if I do something like this, let me actually rebuild everything just in case. And this is going to be something like main.c. What's up, Kolumbetka? Hello. So yeah, right now we're using SDL renderer to do all of this stuff. And if I switch the thing, OpenGL renderer, there we go. and rebuild this entire stuff. We're gonna go into an unfinished OpenGL renderer. So this is gonna be that src main.c. There we go. So as you can see, here is like a demonstration that you know, we can render text with OpenGL, right? All of that is generated on the shader, and we're using the same font, right? We're using the same font. So let me see. We're actually not even setting, not even updating GL viewport when the window is resized, and this is probably one of the things I want to be able to do. So let me see. If I take a look at the viewport, at the documentation of the viewport, GL viewport. So this thing accepts lower, yeah, so the corner where everything starts and width and height. So I suppose we're going to be doing the following thing. We're going to be just making the viewport take the whole window, right? And every time you size, you change the viewport to the size of that window. And because of that, we're going to have a dynamic resolution, right? So resolution is quite important because we pass the resolution into our shader, right? So somewhere here, yeah, here's the resolution. So it's quite important because it's used for mapping, you know, world coordinates to basically project, to do the camera projection, right? Because we have a camera that moves around, and to properly map the coordinates from the world to the screen, we have to know the resolution of the screen. So that's why resolution is very important, and we're going to be dynamically changing it. All right. So in SDL, what's the resize window event? Resize window event. Do we have anything like that? So there is a window event, and let me see what we've got. So as far as I know, there's like 2 of them. So window resized and window size changed. I still don't know the difference between them. Like I remember we kind of discussed it, but it's kind of like weird concept. It's probably maybe some sort of backward compatibility, but I just like don't understand. Isn't resizing basically changing the size? I don't remember. So what's the difference between these 2 window events? But I didn't see the difference. Window has been resized to data. This event is always precedes changed. The window size has changed either as a result of an API call or through the system or a user change in the window size. This event is followed by SDL window event resized if the size was changed by an external event. To be fair, maybe we can just adjust GL view every frame. Is it too slow if we just try to change the GL viewport every frame? Maybe not. We can give it a try because I can always just get the window size, right? So I don't know. We can try to time this function several times and see how slow it becomes, but it shouldn't be that slow. So I'm trying to find the event loop where everything is happening in here, right? So, and let's just try to grab this thing, put it in here, maybe actually in here. There we go. So we have a window, and in here, I actually opened Boomer, and that freaked me out a little bit. Everything's fine, everyone. Everything's fine. So, and sometimes I just how do I open? Oh yeah, sometimes I open Boomer and it actually is, you know, everything stops responding to my keys, and yeah, so I have to not forget to actually quit it. So GL viewport, so it's gonna be something like this. Interestingly, this entire thing, I suppose, is going to be just 0, 0, right? So 0. Width and height is going to be width and height. So this is the viewport, and I suppose we also need to update the resolution uniform, right? Can be expensive, destroying, creating, render. Yeah, actually that makes sense. Yeah, because I remember like I worked a little bit with Vulkan, where you have to explicitly like work with frame buffers, and you had to do that. So we'll probably have to do something about that. Okay, so GL viewport and resolution uniform, right? Resolution uniform. So, and I suppose I'm gonna actually keep it as float. So I'm gonna remove it from here. Do we need anything else? I don't think so. Alright, let's try to recompile this entire thing. It already looks good, actually. Yeah. So, and the proportions are correct, because before, if I actually stash my changes, right, and try to run this entire thing one more time, the proportions of the font were completely broken, right, because the resolution... Well, excuse me. Where is the OpenGL thingy? Why did it... Yeah, here is it defined, and why does it... Why does it open the old one? Wait. Oh, this is because I stashed the changes, and in the stash changes this. Okay. All right. Everything's fine. Everything's fine. I'm just stupid. All right. So, as you can see, proportions are like not particularly correct. So let me do that, and I'm gonna unstash my changes. So I also probably need to update git ignore, right? So where I'm gonna be adding that. Okay. Okay. So that's a little bit better, and okay. So I really like that. So this is the first thing, OpenGL renderer. I did that inside git ignore, yes, exactly. That's what we're doing. Alright, so... update viewport according to the window size. Also dynamically change the resolution for the shaders. There we go. It's really hard to find the music that is just, you know, vibing or something. Okay. So what's gonna be the next thing? So also we need to do viewport like only on resize, but we can do that a little bit later. So I really don't want to spend too much time on this kind of thing right now. So maybe I'm gonna do the following thing. GL viewport, don't update the viewport and the resolution only on actual window change, right? So don't really want to spend too much time. So because you need to choose between like changed and resized, then I don't fucking know, just change the viewport, whatever. So the next thing I want to do, I wanted to actually kind of change the way we render the glyphs. So right now, when we're rendering the glyphs, we are providing like absolute position, right? We're providing the absolute position and also very specific scale. But you know what's interesting is that we have some sort of like a tile renderer, right? We're not going to be changing the scale between different characters. At least I don't see any reason to do so, if you know what I'm talking about. Right, so maybe scale could be a uniform, right? So basically move it to a uniform, and position from being absolute maybe it will become rows and column, right? Rows and column of the cell, right? And the actual absolute position will be computed on the vertex shader. So because right now, when I do GL render text, I had to do these computations on CPU. But I don't really have to, in my opinion, right? So I can just tell, you know, the shader. This is the global scale of the font, and this character has to be rendered at this row, at this column of the tiles, right? And let the vertex shader actually figure out the positions and stuff like that. So this is one of the things I want you to try to do. So interestingly enough, we can also quite easily render cursors. Essentially, the vertex shader can figure out that, okay, I'm rendering the character at the cursor position, so I'm gonna actually tell the fragment shader to render it with a different background color or something like that. So that way I don't even need to have a separate shader for drawing rectangles and stuff like that. I can just tell the, you know, the tile rendering shader like to render the cursor. That's actually pretty interesting. So this is basically what I wanted to try to do, if you know what I'm talking about. So let's give it a try. Interestingly enough, I think this kind of stuff has to become I, right? So because it's going to be actually, you know, coordinates of the tile, and the coordinates of the tile are discrete, right? They're not continuous. There's no reason for them to be continuous, though maybe you can make them continuous, and that way you can create like offsetting overlapping things. Why not? Man, I don't know. So hello everyone who just joined the stream. Hello. So maybe I'm gonna just go ahead and copy paste more of this stuff. Right, so we have a vector 2f. How about vector 2i? And I'm gonna replace 2f with 2i. And can your Vim... well, your Vim can do that, I know that. I do that in Vim all the time, so this thing is gonna be become integer. There we go. Who needs templates, am I right? la.c, and in here we're gonna be just taking this entire thing. And we're gonna do the same thing. Query replace to fi, boom, and in here I'm gonna be doing emax float to int, boom. So maybe I should actually start separating the implementations so it's a little bit easier for me to see them, right? So something like that. Okay, so all right. All right, everything seems to be compiling, and what I want you to do in here, I want you to update my attributes. So we're not going to have scale anymore. Scale does not exist. Scale becomes a global thing. Right, and then position, I don't know, maybe we should call it something like tile, right, at which tile it is going to be located. So because of that, we're not going to have this, and this one becomes the tile. So since this is actually, there's a catch in here. So we create vertex attributes with GL vertex attribute pointer, right, so, but there is a pitfall in OpenGL, very unpleasant one. So essentially it accepts a type of a component, right? And the type of a component can be a GL float, or it can be integer or something like that. But what's interesting is that you cannot use integer in here, or can you? So you have to use GL pointer I think, or I don't remember in which version. So there is something like I, GL vertex attrib, but I cannot see it. So it's gonna be something like I. GL vertex, it's probably, I don't even remember how it's called. Attrib I pointer. Yeah. So something like this. But I don't remember, like, do you still have to use that? It's just OpenGL is so weird. Right, yeah. That's what I'm talking about. So define array of generic vertex array. So it accepts the type, but if your type is integer, it is incorrect to use that function, and you have to use this function instead. So, and the only difference between them is that one is normalized and another one is not normalized, right? So, yeah. And if I'm gonna have the attributes that are not floats and that are integers, I'll have to upgrade my you know, glyph attribute definition, right? So for instance, to include something like type, right? So, and type in this particular case is GL_enum, right? So it's GL_enum type, right? So, and since now our GL definition actually includes types, I can finally change the float, the character from float to integer, right? Because before we did that because I just assumed that all of the attributes can be only floats. So, which is rather interesting. So basically, our entire glyph becomes a bunch of like discrete integers and not floating points. And floating points, we use them for the colors. So yeah, I just find it interesting. That's everything I want to say. All right. So let me actually go through the compilation errors. So glyph position. So this becomes styles. Yeah, this is the tile, and then we're gonna have a type GL int, right? So there we go. Scale not existing right now. Character is correct except it's GL int, and color is correct except it's GL float, right? So something like this. Ch means character. Yes, it is. It means characters. You got it correctly. Ch means character. Okay, so now we have only 3 attributes in here. Yeah, now if I want to just render something at a particular position, I suppose I'm going to be accepting a tile, right? So here I'm accepting the tile, and I don't have to even accept the scale, I think, right? I have to accept the scale, so because the scale is going to be global anyway, right? So we accept the text size, the tile where everything starts, and the color. So, all right. So here is the tile, this is the tile, and essentially we're just adding this thing. Vec I is just going to be I, and this one is just going to be 0. Yeah, so the entire thing here, it actually becomes more simple. Lazy Grid, what's up? How are you doing? Welcome to the stream. So ch will just become an integer in here, scale is not needed. Yeah, so this is precisely why I wanted to make this change, so I can simplify this code. Right, so we moved a lot of these mathematical operations from CPU in this code to the shader. Well, we didn't move it yet, but we're gonna do soon. So we already removed it from here. Now, later, we'll have to add it to the shader. So we're just moving things, offloading things from the CPU, essentially. You know what I'm talking about? All right. So this one is a character. This chat is not even needed anymore. And this stuff is so simple. I can maybe even inline it, like so. Yes, and just remove like that. Look at that beautiful smoke code. My god, such a simple code. Absolutely love it, absolutely love it. I wonder if we can just do something like two. Nah, I guess it's alright. Alrighty. So, and now when I'm rendering the text, I don't have to specify any of this stuff. I can just do y 0, scale is not needed, color is in fact needed in here. So can I render it now? Vec to I s, because it's a single scalar. Is it gonna work? It worked! I mean, it compiled, but it didn't work yet because, as I already mentioned, we removed some code from CPU. Now we have to add it back, but on the GPU. Right, so on a GPU, shaders, fragment shaders. Let's actually start with the vertex shader. All right, so here we have a uniform that is a resolution. So in here, we only have a tile. And I forgot how it's called. Is it IVEC? I think it's a IVEC, right? GLSL. Oh yeah, I remember. It's the binding of IVEC. Yes. The binding of IVEC. Yeah. So it's a vector of signed integers. So we don't have a scale in here, but we do have a scale in here. Character becomes an integer, and yeah, we even send less data to the GPU. Yeah, so that's actually pretty cool. I really like that. We do less stuff on CPU and we send less data to the GPU. It's overall better, I think. So I wonder if I can... Yeah, maybe because of that I can just make this entire thing an integer. Yeah, I think it's going quite well. Alrighty. So where is my tablet? Where is my tablet? So the only thing we know about the coordinates in here, it's row and column. Actually, not really row and column, x and y. So because it's an x and y, do I even pass shit correctly in the GL render text? GL render text. So this is that, and I'm updating x, which is correct actually. Okay, so let me see. So here's the UV coordinates, here's the character size with floats, which is fine. So then we basically prepare the shape of this entire thing and we add position, but position actually is not enough. So we need to calculate position now. So it's going to be a tile multiplied by character size. That's basically the position, but this is not going to compile. This is not going to compile. So on top of that, we need to add a new uniform thing in here. So it's going to be time uniform, right? So we need to introduce scale uniform, and this one is going to be something like scale. There we go. And maybe we can set the scale right away. So it's going to be uniform to f, scale uniform, and let's set it to 5, 5 actually, right? Cool. And in the vertex shader, do we have any problems in the vertex shader? I don't think so. Everything seems to be okay. So now we need to apply the fragment shader. The cool thing about this stuff is that we can change it to integer, and because of that we don't have to have this thing anymore. But that also means we need to rename these variables. Alright, so then we have an index. This is just a glyph. And I feel like this is it. So we effectively did the refactoring that I wanted to do. Let me recompile the entire thing and let's just try to run it. And of course the shader has fallen. It sounds actually quite funny. 19, so what do we have in here? Okay. Oh. If a fragment input is or contains an integer, then it must be qualified with flat. GLSL flat. Deep Singularity, hello, how are you doing? Why? So is it gonna even explain me why? Assignment to a read-only. Okay. Type qualifier used. Okay, so flat. The value will not be interpolated. Oh, I see. That actually makes sense because integer is not interpolatable, right? So yeah. So basically, to explain what the fuck is going on, right? So when you draw a rainbow triangle, right, so if you did a little bit of OpenGL, you're probably familiar with a rainbow triangle. When you draw a rainbow triangle, right, you specify only 3 vertices, and for these vertices, you usually specify only like 3 colors. Like, right, so one is going to be a red, another one is going to be green, and another one is going to be blue. But that usually is enough to create a rainbow triangle. You specified only 3 of these things, but now everything else was interpolated. So if your vertex shader like defines some of the things and send them to the fragment shader, all of the things going to be automatically interpolated to smooth everything out. Right, so, but integers are not really easily interpolatable because you cannot divide them. You can, right, so you cannot divide them continuously. You can only do integer division. So because of that, you can only pass integers sort of in a non-interpolated mode, and that makes sense to me. So I didn't know that before, by the way, so I just learned it. The value given to the fragment shader is the value from the provoking vertex for the primitive. Okay, so that makes sense. That makes perfect sense to me. Thank you. Thank you so much. So I can do something like this. So this is going to be flat. Are you going to be happy? At least this is how I understand it. I could be wrong, by the way. Right, so... so in the fragment shader, storage qualifier must be come after precise invariant interpolation layout. So I suppose must come after precise. Okay, so probably somewhere here, right? I should not actually rebuild everything. Okay. Can you show me an example? So I hate it. So they have to put it here. Okay, so find the 24. So that means I still need this thing in here. So ch. Could replace glyph ch. All right, seems to be working. Invalid operation. Oh yeah, okay. So since I changed some of the things to an integer, right? I suppose I need to also change the GL uniform. Program not linked. Wait, really? So that means linking has failed. Vertex shader output specifies no interpolation, but fragment shader. Okay, so here's the interesting thing. Why linking the program didn't fail? So where do we link the program? All right, so why didn't it fail? Maybe because it was a warning. I see. It probably was a warning. All right, so let me go to the vertex. And so I suppose I'll have to put flat in here. So, okay. This one is rather interesting. So it didn't really work properly, but I'm not really sure why. Oh, by the way, I recently managed to make RenderDoc work on my machine. I mean, managed. I just tried the RenderDoc from the official website, and it just worked. So maybe we can try to use RenderDoc to debug this issue for the first time. And I kind of get how it works, which is actually super awesome. So let's give it a try. I'm gonna put this thing in here. Right, and there we go. All right, so okay, good. That's a lot of different shit. Okay, so if I go in here, render doc bin, I just want to see if it's going to be helpful in debugging this kind of stuff, because it's pretty interesting application. So we go into launch application and we provide the executable path. I suppose I can just do dead and I can just simply launch it, right? So, and I need to press F12, right? As you can see, it tells you just to capture a frame, you have to press print screen or F12, right? So I'm printing F12 and nothing happened because I'm a debugger. That is really strange. It does not react to any of my presses. So why do I have a print screen? Alright. I can't even close this shit, by the way. Press it harder. Huh. Okay, so it does not capture anything at all. That is so weird. That never happened before with me. Is that because I don't handle keys? No. It can't be right. But it just simply doesn't work. Okay, so I don't know what happened. Maybe my keyboard actually died. So JLX gears. Do I have something like this? Okay. Okay, render doc, JLX gears. I wonder if it will just work. Oh yeah, you cannot just, yeah. JLX gears. Can I do it like this? Nah, it has to be full path. Which JLX gears? It's actually in user bin. Okay. User bin JLX gears. Capture a context not created via create context attribute capturing disabled. Oh, it's not even usable in here. Okay, so nice one. Dead. Working directory. What a nice application. I have no idea what is going on. I'm just trying to do dead and working directory just set it to that. I remember it being actually pretty easy to use and it just does not react to it doesn't capture anything like at all. And I fuck. I thought it's not gonna close it, but it kinda did. That does not react whatsoever. Though the FPS is dropping. The FPS is dropping every time I'm actually pressing F12. So I would expect that maybe something is going on. So yeah. Vulkan capture is not configured. Click here. So can I capture inside of the inside of this thing? Oh yeah, I can just capture it here. Okay, perfect. I don't need anything. I can just capture it like that. So did it? It still says 0 captures. Okay, this goes into the trash, I suppose. I tried it. So I tried it off screen and it actually worked relatively well. Why does this program look like a from 90s? Yeah, that's the main problem with this program, by the way. Alright, so whatever, so that means we're gonna do that without the render doc. Like every time I try to use render doc on the stream, it's just like nothing fucking works. Maybe it's OBS, maybe it's not, I don't give a shit. Let me see. Alright, so we can just go through everything we have in there, right? So maybe we're gonna go into the debugger, and so here we set this entire stuff. Yep, I can go into the debugger and just see what's going on. So this is gonna be that, right? So let's break main.c 332. Break main.c 332, and let's run this entire thing. There we go. And what I want you to see in here, I want you to print the glyph buffer, right? So here's the glyph buffer, and so here are the characters, right? So they look good to me. I don't see any problems with these characters whatsoever, so should be fine. So that means something is wrong with maybe a shader. It feels like maybe it's a vertex shader. Maybe it's a vertex shader. Oh yeah, this one is interesting. Okay, so tile is an integer, and here we're multiplying it by a float. So will that automatically convert it to the correct thing? I don't know. Can I just do something like float? Maybe that's what's causing it. I'm not quite sure. I'm gonna rebuild everything just in case. So let me try some other stuff. Scale. Did I set scale? I think I set the scale. Position. So in the font. So what if I just only set the glyph color? Oh! Remember how at the beginning of the stream I was explaining difference between these two functions? Well, thank you very much, OpenGL. Very cool. Yeah, so you need to call a different function, of course. Yeah, if you pass in integers as a vertex attribute, you have to call a different function. So let me see. So here's where we're setting them up, and yeah. So that makes perfect sense. If glyph attribute definition, right? So here's the attribute type is we can actually switch case this entire thing. I think that would be actually kind of cool. So if it's GL float, we're gonna be doing that thing. So this one is gonna be break. Yep. So we're gonna be directly using this type in here. But if it's an integer, right? If it's an integer, we're gonna be using something else. Specifically this function. The only difference between them is that it doesn't have normalized field, because normalization is probably something for the floats, right? Specifies whether the fixed point data values should be normalized, the GL true. Fixed point data values. Can you specify the format of fixed point data? Because I would expect it's working with, you know, IEEE is 754, but whatever. I never used that attribute yet, so I don't really know what it's for. I'm not really sure if I care. Okay, so this one is going to be the attribute. So the size. Might as well, you know, grab this entire thing. Just grab this entire thing and remove that stuff. And this one is I pointer. So that's pretty much it. So, and for the rest of these things, I'm gonna put something like unreachable in here. So this is gonna be assert false, unreachable. Do I even have unreachable macro? I like to create unreachable macro, or to do macro. No, I don't, whatever. Unreachable. So also exit 1 in case you disable this kind of stuff. So that was the problem in here, by the way. That was the problem. I think, I hope. Okay, so that wasn't the problem. Well, I mean, maybe that was part of the problem. Right, so now if I take a look at the fragment, I didn't modify anything in here. So in a vertex, everything is more or less fine. So maybe I should not do this kind of stuff, and it still doesn't work. Okay. I wonder. Maybe render doc didn't work because I was using think incorrectly. Oh, and another interesting thing, like why logging never told me that I'm trying to put GL int in a place where it's not supposed to be. Like it's just so weird. There's so many things that are not convenient in OpenGL. They're just like, they won't work without telling you anything. It's just like, yeah, we won't work because good luck. So. And that's kind of like the default in OpenGL, and it's just like, oh, for fuck's sake, this shit is not designed for programmers. I don't know for whom it's designed. Okay. I have log enabled. You know what? I'm gonna make a small break and make a cup of tea because already streaming for 1 hour and I think I need some caffeine. So, all right. So I was thinking that maybe the render doc wasn't working because we're not using the right thing, the right GL vertex pointed function. So I'm thinking that if I try to use it again, will that work? It's rather interesting. So I hope so. Q render doc. Okay. Doesn't work. No, it doesn't work. So, alright, not gonna rely on this thing anymore. So... So maybe I didn't set up the scale. I actually set up the scale. Yeah, I also like how it doesn't even tell you. Like, welcome to modern software, I suppose. Right? No modern software actually tells you shit about anything. Vertex. So this is UV coordinate. So what if I don't use the tile? Right. What if I don't use the tile and I use specifically something like character size? Right. So yeah, so the modern software just pretends that it's working, but in fact everything is broken already, a long time ago. I worked in the industry long enough to actually know that firsthand. I was even explicitly told to write software that pretends that's working, and that's why I don't want to work in the industry anymore. Because it's fucking disgusting. Alright, so do we have in here? promote it 1 constant, compacting. So I'm thinking maybe, what if I did something like UV and gel position, right? Gel position. Frag. And then we can simply actually ignore everything in here, and I'm gonna just set color to be, I don't know, red. Too many parameters, vector 2, yeah, I do agree with that. Well, I mean, everything's working, so I don't know what I expect. But now we can try to do some other things. Right, so we can set up the character size. Multiply by character size, and should be pretty simple. Didn't really update anything, so maybe we have to do project point. And so that thing will become small. Yeah, here it is. Here is a small thingy, Majingi. The next thing we can do, we can try to apply the scale, right? So here's the scale, and scale is perfectly applicable. And then we need to add the position. So here is the position, right? And okay, so depending on different position, you're gonna have different things and so on and so forth. So what if position is actually tile character size? Okay, it actually worked. Nice. And what's interesting is that this is identical line, so this is working. I'm really happy about that. So can we set different glyph colors? I suppose, for instance, vec4 01010, right, and a fragment shader, right, so it's still red because in the fragment shader we don't take that into account. So what we have to do here is glyph color, right? So will that work now? Yeah, so now I can change the glyph color from the vertex shader, which is nice. Right, so it could be yellowish. Nice. And so here I can just set the color, and it's supposed to be passed. Okay, we found an error. All right, that's very interesting. The color is fucked up. That's how we debug shader kits. So yeah, this is a shader step debugging. Literally line by line bisecting where the shit happened. Especially when the render doc doesn't work. Like that's what you have to do essentially. There's no printf debugging. There's nothing. So yeah, that's the problem. The color is not passed correctly. So yeah. So you can set the color in here like so. Well, yeah, of course, semicolon. But the color is just not properly set. No, I don't know why. Okay, so let's go. Ooh. So the color is a bunch of floats, right? The color is a bunch of floats. The tiles are set correctly, by the way, which is kind of cool. They're set correctly, but yeah. So here's what we're setting in here, so blah blah blah. Gel vertex pointer, so here's the type, component. If the type is a float, we're using that thing. Otherwise we're using that thing. All of the offsets have to be properly set, I think. So I don't see any problems in here. GL render text, right. Oh, of course. Because we had 4 attributes And then I changed the amount of them and I forgot to update this thing. Okay. Alright, classic. Alright, now it works. Vertex, and I suppose now we can pass the glyphs and shit, and now in a fragment, alright, so we can try to render this thing like that, and well, it almost worked, actually. It almost worked. Which is rather interesting. Alright, so something is not particularly working, right? Though it rather depends. So tile is 0, right? Tile is 0. Yes, it is 0. CH is 1 and the color is 1 as well. So I don't think there are any problems in here. So let me take a look at the fragment. So here is the CH, we set it in here. Then we check whether it's within the ASCII range. Then we create an index out of that. So we have font columns. So and I'm trying to figure out what does code are used to concretely. Concretely. It is used to make the GPU on your computer heat up. Yes. So essentially, like your GPU is like an engine, right? So it needs the fuel to actually heat up and move. So, and the fuel in that case is a code. You feed it the code and your GPU heats up. It burns the code. That's how it works. So, concretely, this is as concretely as I can get it. So, yeah, so basically you use code to turn your computer into a heater. Like when you have a fireplace at home, you use just like wood logs as a fuel, right? So in case of a GPU, you use code as a fuel. You're welcome, you're welcome. So feel free to ask any question about programming. I've been programming for quite some time, I can explain anything to you. So, alright. Very, very interesting, not gonna lie. Especially pro-life tips, exactly, you know it. So maybe there's something wrong with the vertex shader. So this one doesn't take into account the scale. I think that's the scale. Boom. So now we actually sent you know, this text to the GPU as integer ASCII characters and positions also as integer ASCII characters. This is actually quite awesome. I really like that. So if you want to render something on a different line, right, so here's hello world, right, and so it could be something like foo bar, bar with a different color maybe. So this one could be something like this. So foo bar, and here we're going to be using row 1 for the foo bar, and we're going to use the green color, right? So, and it didn't work because I didn't recompile everything. Okay. Very POG indeed. Is it Node? I think it is. Okay, so, oh, actually, okay. I just realized that the coordinates are completely inverted, right? Luckily, I think I can use negative coordinates, if you know what I mean. I'm pretty sure I can use negative coordinates in here. Yeah. So, yeah. Yep. Yep, indeed. So here we have a tile renderer, and that is actually very cool. The thing is, I want to add the support for the cursor. Yeah, so we recently renamed the text editor to DED, which stands for Dramatic Text Editor. For those who doesn't know why it is called Dramatic Text Editor, it's because of the way you interact with it. Right, so let me actually demonstrate you. src main.c. So I need to rebuild it one more time. Are you freaking serious, mate? This is not a correct thing to... Okay. So this is how it looks like, right? So this is the text editor, and I'm not even fucking joking. So this is how we do that. And if you start it like from scratch completely, right? So this is how it looks like. You start typing, right? Your code, and yeah, that's basically the text editor experience. And what we're working on right now, we're working on rewriting the renderer from pure SDL2 to OpenGL so we can have epic shaders, right? So we want to be able to apply some interesting effects and stuff like that. Without a proper OpenGL renderer, we cannot do that. So, and that's what I'm working on right now. Yes, it's a text editor for the epic gamers, that's right. World. Yeah. You can also navigate with the mouse. Recently somebody actually contributed that. And this thing is open source if you're interested, so you can find the source code in here. This falls under things I never knew I needed. Yeah, exactly. Alrighty. Alright. I'm gonna remove render doc because it was never helpful anyway. So pass I don't know, implement proper tile renderer. So this is going to be the proper tile renderer now. Proper tile renderer. Okay, so let me see. I want to have the cursor, right, if you know what I'm talking about. So maybe we're going to pass the cursor as a uniform to the shaders. Right, so here are the uniforms, and I can say something like IVEC, the binding of IVEC, cursor, right. So this is going to be our cursor. So, all right. Uniform. So GL int cursor uniform. Is this an ads in my chat? What the fuck is going on? Alright, cursor uniform, get uniform location. Program cursor. Alright, so, and I can set the cursor to... Yeah, let's actually set it to something. Right, we'll just set it to something. Cursor uniform. I think it's gonna be to I. Cursor uniform 0, 0. There we go. And now, what we need to do in here is essentially knowing the cursor. Yeah, so here's the cursor and here's the tile. And if that's quite important, tile is equal to the cursor, we have to like swap the colors, right? So yeah, we need to render everything in a different like background thingy. Which is rather interesting, which means that we need to pass the background color to the fragment shader. We don't really pass the background color at all, but maybe we should start doing that. So this is a glyph color. So maybe I need to actually call it something like glyph FG color, meaning foreground. Okay, this looks like an ad, so I suppose this is like 2 hours timeout of some sort, so I don't know what the fuck is going on, and I don't even want to try to understand the situation. Just 2 hours timeout, thank you. Alright, so FG, here's the color. Okay, so in the fragment shader, we're gonna accept this entire thing like that. Query place. FG, and there we go. So this is the foreground, and we need to introduce the background as well. So the background is going to be rather interesting. So here's the output vec4 glyph background color. Right. So and right now the background color, as far as I can tell, it's a BG. Is going to be everything like 0, right? So it's going to be completely transparent with you guys. And how can we even apply this entire shit? How can we apply this entire shite? CD, exactly. So, you see, texture has background pixels set to alpha 0, right? It is alpha 0. And we want to replace all these pixels with the background color. There we go. So, and how can we even do that? How can we even do that? So, if it's 1, we can take the texture color like this, right? Here's the texture color. So there we go. And here, this thing is as simple as multiplication. Right? Then we can take the alpha of the texture, right? Alpha of the texture. So it's going to be something like T. I think alpha is W, right? If it's 0, I want to add a new color, right? So maybe not only 0, but rather, yeah, can we invert it? So I'm gonna actually subtract it from 1. So if it's 0, it will become 1. If it's 1, it will become 0, and so on and so forth. Right, and then I can essentially multiply it by background color, right? So multiply it by background color. So, and here's the interesting part. If the alpha is 0 in here, this entire thing is not going to be visible whatsoever, right? It's going to go away completely. But this thing will probably show up, which is not 100% true. I suppose, yeah, what we have to do in here, is maybe multiply everything by this thing as well, right? So, yeah, I guess something like that. Roughly. TC, TC, TC. So because we already have T, right, and TC is the color of this thing, right? Hopefully that will do something. So I don't have to rebuild the entire thing, and well, I do need to rebuild the entire thing because we're using incorrect renderer. OpenGL renderer, so let's enable this entire shit. Right, and let's do something like this. So this is going to be dead. Okay, so overall it seems to be working, right? But now, can I try to set the background color to something, right? In the vertex, let's set it to white, right? So we're going to be setting it to white. And it didn't work. Yay! That's super cool, actually. I really like the fact that it didn't work. So let me take a look at the fragment. I wonder what's gonna happen if I put this thing like that. There we go. And yeah, so the background color is there. I don't see any problems in here. So interestingly, can I just do something like this? Wait. Yet again, I made almost the same mistake as in SDL renderer. There's no alpha things in there. Okay, let me show you something pretty cool. TC glyph FG, right? Glyph FG. If you take a look at this thing, it looks like each glyph has a transparent color as a background. Right, so here you have a green as a foreground, so this is a green as a foreground, and transparent as a background, but this is not true, and I'm gonna show you why. So if I change this thing to slightly grayish tone, right, so let's actually make it slightly grayish, like this, not slightly grayish, but like half of grayish, and we'll have to rebuild the entire thing. Build. Build dead. So yeah, it is not true. So it never actually had any alpha equals 0. If you know what I'm talking about, it never even had that in the first place. Which is rather interesting, I think. I do think. So let me see what we've got in here. So yeah, as far as I can understand, yeah, you don't even have to worry about that. So like you don't have to even multiply by the full color. You can just take the first thing like X, and that will work fine. So that means we can use that X to blend everything accordingly. Yeah, okay, so this already works perfectly. And that means like in here I can take the background color, right? Multiply it by the inversed TCX and add it in here like this, right? So if I try to do something like that, there we go, we have a customizable background. Alright, so that makes sense. We have a customizable background. This is actually pretty cool. Alright, and now we can use that to emulate the cursor, right? We can use that to emulate the cursor. So for now, I'm gonna just go ahead and replace this entire shit like so, right? Okay, so before I do that, let's make a small break using this. Let me see what we have in here. So what I want to do, I wanted to emulate the cursor, right? How are we going to be emulating the cursor? That's a very interesting question. I don't want to do any branching, if you know what I'm talking about. Right, so that means we have to do a branchless programming. So an indication that the current tile is equal to the cursor, right, is that both of these things, right, if you subtract tile from cursor, this entire thing should be equal to ivec2 0 0, right? So that's how we know that they're equal. And if they're equal, what we need to do, we need to switch the background color and also maybe a foreground color, I don't know. So the easiest way to do, like right now, is just with the branch programming, I suppose, is just do if cursor equal tile. If they're equal, we're going to be setting the glyph fg color to, we can set it to black, right? So this is going to be just black. And the background color, so the background color is going to be just white. Otherwise, we're going to be setting this entire thing like that, right? So maybe it's going to be sufficient enough for now, but in the future it would be nice to get rid of this branching. But I don't know, maybe it's fine, maybe it's not that bad. Okay, so, and it didn't work because we don't have a vec. It's actually vec 4, right? So this is a vec 4. And the background in here has to be, you know, nothing, I suppose. Foreground has to be black, so that means maybe... No, we can actually make it transparent, why not? I don't see any problems with that, to be fair. That will be actually rather interesting. Okay, so as you can see, we have a cursor now. So, and that cursor is just like, you know, determined in the... on the level of a shader, right? So it's on the level of a shader. Interestingly enough is that... we can try to control the cursor with the keyboard. Yeah, that's actually very interesting. So let's actually try to control the cursor with the keyboard. So because there's a very interesting thing. The cursor won't be able to go outside of the... It won't be able to go outside of the string. This is rather interesting. Okay, so if we have SDL key down, right, so this is SDL key down, and I switch on event key, key sim, sim, and we're gonna have like several of these things. SDL key left, right, SDL key right, up and down. Right, and we also need to keep track of the current cursor. So can I do something like vec2i, and I'm gonna call it a cursor vec2i s. It's initially gonna be 0. All right, and on every frame in here, we're gonna be doing something like gl uniform to I, cursor uniform. Cursor, cursor X, cursor Y. There we go. Cursor X and cursor Y. So in here we can do something like break. Right. So if it's the left, cursor X is gonna be subtracted by 1. If it's right, it's gonna be actually edit. Right. So then X up. I suppose it has to be plus because the positive y goes up, right, and down is going to be actually -1. I think that's how it's going to go. To make it a little bit more symmetrical, maybe one of the things I want to do in here is something like this. And let's try to recompile this entire stuff. So vec2i has no effect statement. Am I blind? la.h. Ah, okay, so I see. All right, so everything's fine. Okay, and as you can see, I can move it. So interesting part is that if I go outside of any of these characters, right, the cursor becomes invisible. This is because the cursor is only rendered when you try to render the character. Right. You see what I'm talking about? It's only rendered when you're trying to render the character. Otherwise, it's just never rendered. That is very interesting. So maybe because of that, the cursor has to be rendered as something else. So you can try to render the cursor as additional character. But here's the interesting thing. What if you have several characters in a shader with the same row and column? Right. Are they gonna start z-fighting with each other? Or which one is gonna be printed first? That's a very interesting question. Which one is gonna be printed first? So maybe we need to introduce like a z thingy in there somehow. That would be rather interesting. Or maybe the cursor could be a completely different shader. That's also an option, right? So it could be a completely different shader. Why not? But that also means we need to do 2 draw calls. The first draw call draws all the characters, and the second one draws the cursor. But that's not that bad, I think. So I don't see any problems with that, if you know what I'm talking about. Yeah, I guess we could introduce the second shader specifically for the for the cursor, right? So it's gonna be the cursor shader. But for now, what I wanted to try. Yeah, I want you to see if you render 2 texts at the same location. How is it gonna look like, right? So here we have hello world and foobar, and we render them on different lines. But what if I try to render them on the same line? Which one is gonna be more visible? On top of that, I think I wanna actually rename this entire thing to like sized. Right, so this is sized, and have the second version in here, gl render text. Const char text, which accepts the current tile and the color, and simply calls to this entire thing, right? So it's going to be 13, like that. So this is going to be the text. Then we have strlen text. I like the simplicity of this render. Like, it's kind of weird that, yeah, I just put the text in there and where it starts. And it just works. Alright, so the color incompatible. Oh, because it's a 4F. Yeah, it's a 4F. I'm gonna sneeze, by the way. I'm gonna sneeze soon. Debated, by the way. I'm not gonna sneeze. So too few arguments. Oh yeah, this one has to be S. This one has to be S. Yeah. Alright, so it's kind of weird that it first drew the foobar. Huh. But I suppose the order shouldn't be actually defined. I don't think the order is defined in this particular situation. I don't think so. But it kind of is. But yeah. According to my understanding of shaders, right, it just shouldn't be defined that easily at all. So maybe we should not even rely on an order in these kind of situations, right? Yeah. And so if we're gonna be doing the cursor, right? If we're gonna be doing the cursor, what's the best way to do that? I suppose we can just do 2 draw calls. The first draw call renders like the whole buffer. The second draw call renders the cursor. Yes. But you also need to do this kind of thing. Yeah. Okay. I think that's fine. I think that's fine. And because of that, in the main shader, in the shader itself, we don't need the cursor thingy, I suppose. So we don't need the cursor thingy because all of that is going to be completely customizable. So the same thing, the background. Yeah, okay, so we need to be able to customize the background and foreground. Right. So right now we only have, foreground. This is FG color, but we need to introduce another attribute in here. So before we can continue doing interesting stuff. So where's the glyph attribute? So here is the color, and we need to rename it to FG color. This is the FG color. And the second thing we're gonna have here is BG color. And because of that, this is gonna be like this. All right, so let's go ahead and implement this into, I think we're gonna go to the compilation errors. Right, and see. All right, so we don't have this stuff anymore, so we need to edit like this, and then we're gonna put it like that. So BG, 4 components, float, everything looks okay. All right. So what's going to be the next one? So this is FG color and this is BG color. Anything else? So now we have 4 of this stuff. So here's the color. So in these functions we accept only 1. So maybe we need to start accepting 2 of them. This one is going to be FG color, and this one is going to be BG. Right, there we go. All right, so in this one, actually, like this, 4F. Okay. Commas. Ki komrat. FG cola, BG cola. Ki komrat, exactly. So this has to be BG color. And now, as we do this entire stuff, I suppose we can say that the background color right now is going to be something like this, right? So there we go. Okay, so looks good. And now from the CPU I can control this entire thing, right? I can probably control this entire thing. Didn't work. What the fuck? Oh yeah, because we actually don't accept this stuff on the shader side, right? So this becomes FG, right? And the third one becomes BG color. And this is basically FG color and BG color. There we go. So we're wiring everything up. Hopefully that will start doing things. There we go. So now we have a tile renderer where you can control foreground color, background color, and so on and so forth, which is quite convenient. And this is something that we can use to emulate the cursor and so on and so forth. So yeah, with this like kind of coloring, we can also start introducing like syntax highlighting and whatnot. So it's actually pretty good. Interestingly, this is pretty much it. So we have a pretty solid renderer that we can try to integrate into the main application. Yeah, so we already have it. We just need to start using it. So that's pretty much it. Let me see. So what we did in here, we introduced background color for the... So I can probably remove everything related to the cursor right now, because we're going to introduce the cursor as we integrate everything. So this is going to be that. And I'm going to just take this entire thing, right? I'm going to just take this entire thing and recompile everything. Okay, so there is no this stuff. We don't have a cursor uniform at all, right? So cursor uniform, we can easily remove this entire thing. Let's go to the compilation errors. So how many of them do we have? So this is another one. All right, everything's okay. Everything's okay. Introduce bg color vert attrib for glyphs. Vert attrib for glyphs, and I'm gonna push that right into the repo. Okay, go. Okay, go. So let's go ahead and integrate the main application. Let's integrate the main application. How are we going to be doing that? So one of the things we have in there is that, so we have an editor. I think I'm gonna just compare things side by side. So here is the previous one, and here is the new one. So the first thing we do in the previous one, we set up the file, right? So we're loading the file and stuff like that. So that makes sense to me. Let me try to compile. Is it gonna compile? Hopefully. Okay, looks good. Yep. So is that the OpenGL one? So this is the OpenGL, if I understand correctly. OpenGL, and I want to mark that main as SDL, right? So we can easily, not DSL, SDL. All right. So, and let's go in here. So we initialize everything, so it's the same as anywhere else. So then we start in the ticks, and then we're controlling this kind of stuff. Okay. So okay, now I'm gonna take this kind of thing and just copy paste it there. I'm not sure. Is it the right thing to do? Yeah, I think it's the right. So we also have text input and some other shit. That's a lot of different shit, not gonna lie. So I'm just thinking how I'm gonna copy paste in this thing. Can I just copy paste the whole event rendering? I think I can just copy paste the whole event rendering. So OpenGL. So here it is. Then while and then here's the whole event rendering. But another interesting part. So in a different event renderer, right, we had more than that. We have event and we also had a start. Oh yeah, we were doing synchronization for the FPS, but we can do that a little bit later, I suppose. Okay. So is it going to be compiling? Let's go through the compilation errors. It is in fact compiling. All right. So here's that. Then we have the cursor position. Then we set up the camera, and we might as well also put this thing in here. All right. So update the size. So here we are actually setting up the camera. So that makes sense to me. That makes sense to me. So the camera has been set up. Now we need to render the main text, right? So we are rendering the main text, and then we need to render the cursor. And the way we're going to render the cursor is rather interesting. So maybe we're going to do that a little bit later. So OpenGL. Where I wanted to put this entire stuff. Okay, so we set this, set uniform, and I suppose I'm gonna put this in here. So here we're like rendering the rows and whatnot. Right, but instead of, we don't even need to do any projections. That's the cool stuff about it. Like all of that projection mapping, it's already implemented in a shader, which is kind of cool. So we want to move it in here. So what we need to do in here is GL render text. All right, and in here, what's the signature of this entire stuff? So I provide the line. It actually has to be sized. Characters, line size, it's the amount of characters. And I keep forgetting what's the stuff in there. Should have actually copy pasted everything accordingly. Am I in the right renderer? I'm not sure. Yeah, I think I am. So it's gonna be line characters, line size, the tile, the most interesting part, vector I. This one is rather interesting. So column. Column could be 0, whatever. Row. Row has to be negative because we're rendering from 0 to n, but this is OpenGL coordinates. OpenGL coordinates go from -1 to 1, -1 to 1, so they're like y goes up. That's why we're gonna set the row as negative. So that's basically what we're doing here. The foreground color is gonna be white for now, so that means it's gonna be vec2 IS1 like this, and the background is gonna be completely transparent with you guys. Like this. There we go. So, and that is pretty much it. That should render everything accordingly. This won't render the cursor, but we're gonna implement it a little bit later. All right. So let me see what's going on. GLI actually has to be, yeah. This one has to be for. 4fs vec 4fs. There we go. Is it gonna work? I think it kind of worked. Yeah, I think it did. Essentially because we just rendered the text. We sync. Yeah. Okay, that makes sense. So every time we finished rendering, right? Every time we finished rendering, we need to synchronize the buffer. So it's going to be glyph buffer sync. So we're basically sending all of the data to the GPU, right? And before rendering anything, we can actually need to clean the buffer, right? We need to do glyph buffer clear, right? So we remove everything from the glyph buffer, we put glyphs into the buffer, and we synchronizing it, sending it to the GPU, and then we're rendering everything. So as far as I know, we don't have glyph buffer clear. We'll need to implement it. Yeah. So glyph buffer push. I know that there is glyph buffer push sync and glyph buffer clear, right? It's not going to accept anything, and the only purpose of this entire thing is to actually set the count to 0. There we go. So that's essentially what we're doing in here. All right, so yep, it's kind of working, and now I should be able to open the file within the text editor. Oh shit, there's too many glyphs. All right. I think we need to actually allocate like a lot of data in here. So how much? I think maybe 640 kilobytes should be enough for everyone. So I have an idea to implement a renderer that is not limited by the amount of glyphs it can render. So essentially it's going to have a fixed buffer, but once the buffer overflows, we basically flush it into with a draw call and continue appending it, right? So I want to implement something like that. But to be fair, so we should call some of the glyphs, right? So we shouldn't actually try to render all of the glyphs. So the main problem in here is that we're trying to render all of the glyphs at once, and this is kind of like unoptimized and a waste of time. So we'll see how it goes. All right. So I'm just extending the buffer. Hopefully, there we go. So this is rendered with OpenGL renderer. So we don't have the camera movement or anything like that, but all of that is already rendered with OpenGL, and we can probably try to prove that by doing something interesting with the colors. I don't know. We can multiply this kind of stuff with like a rainbow stuff, right? And a rainbow stuff. We even depend on the time, right? We even depend on the time. Yeah. So we're gonna do HSL. Yeah. We can try to do HSL, literally. But not sure if... let's actually do something simpler. So it's gonna be sine time, cosine time, sine time. And this one is gonna be something like this. Okay, so if I try to run this entire thing now, and it doesn't compile rainbow undeclared because it's a vec4. Well, yeah, so this is kind of shit that you can do. So it was not really possible in SDL, right? It was not really possible in SDLs, but now it's possible. I think it depends, right? So if you add UV in here, right, something like UV plus X, then UV plus Y, and here you have UV plus X plus UV plus Y, and also it would be nice to have a function that maps to 0, 1. So essentially it gets the value from -1 and 1 and maps it to 0, 1, right? To do that, so we have something like from -1 to 1, right? And to move this entire thing, first thing you want to do, you want to multiply it by 2, right? So, no, you want to, I think you want to add 1, right? If you add 1 to both of the ends, you're going to have 0 and 2, right? And after that, you can divide this by 2, and that will turn it into 0, 1. So this is how we can map -1 to 1 to 0 to 1. So it's actually quite convenient. And then we can just do map 0, 1 like this. Maybe there is like a better way to call this function. I'm not a computer graphics engineer, so I don't know the terminology, right? But I think map 0, 1 is rather fine name, right? Because the core is expected to be from 0 to 1, but sine and cosine produces value from -1 to 1, and you definitely need to map it properly. So, so this one is 26, semicolon. All right, that's actually pretty cool. That is fucking awesome. I don't know if you can see that. I can zoom in a little bit by changing the scale, scale uniform, right? And when we set the scale uniform, I can set it to like maybe 2020, right? So okay, so let's actually build. So now this kind of shit is possible with OpenGL renderer. So we spent like 2 streams to implement this kind of stuff, but now that's what we can do. I think it was worth it. I think it was definitely worth it. Yeah. We've got shaders. We've got shaders. Oh, you know what's also cool? We can control individual coordinates, like absolute coordinates of the tiles in a vertex shader, right? Even though we're sending tile coordinates from CPU, those tile coordinates eventually needs to be mapped to absolute coordinates on the GPU. So it means on GPU we can also animate absolute coordinates of the tiles and do something with them. I think it would be actually kind of interesting. So if I actually make this kind of thing smaller, so we're gonna have specific characters in there, right? So, and I go to the vert, right? So I'll go to the vert, and what we can animate in here, I think we can try to just make it move around or something. Just make it move around. So it's gonna be some sort of a value. I don't know, T. And it's gonna be vector 2, sine over time and cosine over time. So you also getting a PhD. I'm pretty sure I already got one. So shit. Yeah, there we go. So I'm uploading a texture on the GPU, and I'm looking up the glyphs in a fragment shader like this. So I'm literally like handling ASCII characters, and I'm using ASCII characters to actually find position in the texture. Is this PhD worthy, by the way? I don't know. I actually did that already before, the entire meme about PhD and glyphs on GPU, so I didn't know that it's PhD worthy. Fuck. Oh my god. This is the best meme that came out of Casey community. It's just absolutely beautiful. I absolutely love it. All right. Let me see. So what I was trying to do, I was trying to actually update the vertex. I can see scientific novelty in here. This is because you don't work at Microsoft, okay? So if you were, maybe you saw it, right? You need to work at such a advanced company as Microsoft to actually see the scientific novelty, right? Anyway, it's too deep buried under the shaders. So if I do something like this, it's gonna be sine time cosine. So, wait. So cosine is x, right? Cosine is x, and sine is y, right? There we go. This is just basically a vector, right? So we have a vector that's just rotating like this or something, right? We can make it maybe smaller, but it's actually a vector from 0 to 1, so it has a, well, I mean, it has a length of 1. One of the things we can do with this stuff is we can take the position, right, the actual position, and we can multiply that position by that specific vector. We can call it something like shaking, right? We're multiplying it by shaking. Yesu, kawai fokendesu. And, okay, time is undeclared. Alright, so let's actually declare them. Why not? Don't see any reasons. Can somebody issue command for the numbers, please? I don't remember. It's relative numbers or something like that. Time. Holy shit. Well, I mean, this is not what I wanted. But that's even cooler than I wanted. So yeah, this is... Alright, not bad at all. So this is how crazy you can go if you start using OpenGL. Essentially, actually, I think I just wanted to do plus. Yeah, I think that's what I wanted. Yeah, and you can't see that shit because you need to have like intensity. Right, so in float intensity is gonna be like 10, right, so it's gonna be 10. This one is interesting. Okay, so they're rotating in unison, right? So this is not intensity, this is amplitude. There we go. So this is the amplitude, and you can change this amplitude to like 100 or... this is actually too much, I think. Alright. So, but because... yeah, this is kind of lame. So maybe one of the things we want to do in here is to use the actual tiles in here to offset things around a little bit, right? So for instance, I can use tile X in here, and here tile Y. And that, like, depending on these, on the characters themselves, they can be offset slightly differently. So that's what we have in here. So... and all of that done in the shaders, by the way. So that's pretty cool. Maybe if we change the intensity to like 10. Speaking of programming under LSD, so... So it's gonna be like around 5. This is beautiful. I really like that. Sodium trip, exactly. Anyway, so enough of the shit, because we need to finish the integration. We need to finish the integration of our nation. If you know what I'm talking about, we need to finish the integration. Okay, good. Okay, good. So, and I need to probably synchronize the FPS and whatnot, right? I think synchronizing FPS is quite important in here. OpenGL, so it's gonna be while. Here we start that, and then at the end of this thing, we're doing the duration shite, and we put this stuff in here, so we do a little bit of a delay. I'm sorry. Okay, to be fair, do we really need to do FPS for... Well, yeah, we do need to do that because we're going to be animating the camera on CPU. The camera is going to be definitely animated on the CPU, so... the camera is going to be animated on the CPU. Do I need anything else? I guess we can try to actually animate the camera right now. Right, so I'm gonna go to the uniforms. Right, so we have a time uniform, and I'm gonna introduce something like GL int camera uniform. There we go. And where do we get all of these uniforms? Scale camera. Boom. And in a vertex shader, we're going to have, well, I mean, it probably has to be a camera position, is it not? Let's call it camera, whatever. Vec2 camera. So camera is already at the center of the screen because of the specifics of OpenGL. Right, so after we mapped this entire thing onto the screen, so if the point is located somewhere here, to the right, I have to be subtracting the position. Okay, so that means I need to subtract the camera from the point, right? So I'm subtracting the camera from the point. Then I'm mapping it to the screen. Not to the screen, but to NDS, normalized device coordinates. So yeah, I think that should be enough. And I need to recompile the entire thing. So we're already handling the camera uniform in the GPU. Now we need to actually send the camera coordinates to the shader, right? So here's the time uniform, resolution uniform. So let's do something like camera. So it's gonna be 2F. Camera uniform, and here we're gonna have camera position X, camera position Y. There we go. So we're sending the camera position to the GPU, which is pretty pogue in my opinion, I think. And something went completely wrong. I don't know what exactly. So camera, so if I don't subtract the camera, what's gonna happen? Something, wait, what happened? I didn't even do anything. What the fuck? I didn't do anything special. I'm an idiot. Okay, everything's fine. I should open with a specific file. Alright. Well, I can already edit things, but the camera is not animated for some reason. So camera velocity, camera position. Why are you not... I disabled it because... Alright, that means I'm already getting tired, so that's fine. That happens. We all are people, humans I mean. So... Alright, so that's pretty... Oh, this one is interesting. So it is broken on Y, essentially. It is broken on Y, so that means in a vertex, Oh, we have to do it slightly different, so I think it has to be like a vec2. Oh shit, maybe not even. So when we're computing the cursor position, right, so here's the cursor position. What I have to do in here, I actually have to take the negative row, I think. think the row has to be negative. Yes, yes, yes. Oh shit, of course. Fuck. Editor. I'm not even sure. Well, I mean, I can always just do something like this. Why wouldn't it work? I'm really surprised. Okay. So my brain is already starting to work, so that's why I can't figure it out, because it involves a lot of different things in here. All right. But theoretically, by the way, this should already feel like the original renderer. I can do shit like that, which is pretty cool. And that is OpenGL, by the way. That is OpenGL. So that's pretty poke. And oh yeah, it went on the second. Huh. And it didn't work. Yeah, something's definitely. This has something to do with the with the coordinates of the row of the cursor and the camera, like OpenGL, you know, because the Y goes up in positive in OpenGL, and we used to do that in negative. So yeah, I think I want to make a small break and make a cup of tea, because yes, I'm definitely actually falling asleep a little bit. So let's make a small break. Alrighty, what do we have? We have a not working code, which is pretty sad, not gonna lie. So what we have in here is that we have rows and columns, right? And yeah, essentially, like, rows have to go to negative, if I understand correctly. Oh yeah, so let me try to understand this kind of shite. So this is X and this is Y, and this shit is 0. And interestingly enough, so 0 corresponds to this kind of thing, right? So here is 0, and this is the row 0. So row 1 is supposed to correspond to something like -1, right? -1. So that means the position, if you have a cursor at -1, right? Its position should be somewhere there. Its position should be somewhere there. And is it going to be the case though? Font scale. Font scale. I don't think this is a correct thing to have. So we have a slightly different font scale. Yep. I see what's going on. So we have a hard-coded font scale. So maybe the first thing I need to do, I need to specifically set the font scale to be the one that we had coded initially. So this is the scale, and it's going to be font scale. Right. So is it going to work? Let's rebuild everything. This is dead. SRC main, and all right. So seems all right. So it's a 1. So the camera. Where is the camera? So this has to be just negative. Character height. It just like flies away somewhere. It simply flies away, and I don't really understand why. Maybe we could probably trace this value somehow. What if we just print f the cursor position, if you know what I'm talking about? So in cursor position we do that, so it's gonna be just f, a bunch of f's in here. Cursor position x, cursor position y, and let's see what's gonna happen in here. So we'll need to rebuild this entire stuff, but I don't want to run it from the Emacs because Emacs is pretty slow terminal emulator. So I probably want to do it somewhere here, right? So, and if I go down, okay, so this one is interesting. Oh, something overflow. Okay, so that's pretty cool. Thank you so much. So the cursor row, it's size T, of course, freaking of course. So the first thing I need to do then, I need to convert it to integer and only, okay, that's freaking, yeah, freaking classic. Rust borrow checker would have caught that, by the way. Yeah, now it works perfectly. So now we can navigate here. And we don't support the mouse, I think. I don't think we support the mouse. But maybe we should actually. So let me quickly see if I can't port the mouse stuff that was recently submitted. Mouse button down. Okay, so if this is OpenGL, and I go down to the while not, mouse button down should be there. So here's a mouse button down. Right. Oh, it's mapping the window coordinates incorrectly. All right. Mouse click. This is a strange code. Let's put it like this. To do mouse click is broken because the coordinates need to be mapped differently. The feature was initially introduced in the pull request, as far as I know. So let me see. Come on. So it was even broken. Holy shit. Basic mouse integration. Okay, so it was 14. Right. So I don't care, to be fair. Okay, so here's the cursor position, and yeah. So everything looks okay, more or less. The only thing we need to draw now is the cursor itself. Right, we need to draw the cursor itself. Interesting part about the cursor is that I think it should be really easy. So we do glyph buffer clear, so we clean the buffer, and we only want to render a single glyph. Right. Render cursor. Maybe I'm gonna actually re-implementing render cursor, but for the OpenGL. Right, so we're gonna be implemented for OpenGL. So it would be nice to also do that in a separate draw call, just to render everything on top. Not necessarily. Okay, so we have a GL render text, and we're gonna have a GL render cursor. We don't need the renderer, we don't need the window, we don't need any of the shit. In fact, I think all of that is completely redundant. All of that is completely redundant. The only thing we need to be able to do, we need to be able to take the character under the cursor, right? So we're taking the character under the cursor. Wait. And if it's available, we have to draw everything accordingly. So that is fine. Interestingly, so we set the color, we set that. So GL render text, and we're rendering depending on what we have in here. So sized, right? So sized. If C is available, we return C as otherwise space. The size is always going to be 1. The foreground, as far if I understand correctly, should be completely transparent with you guys, and then vec for fs has to be, so this is a background, right? The background has to be white, right? And that's the whole thing, if I understand correctly, right? So you just check if there is a cursor in that place. Oh, you also need to set up the coordinates. Okay, so it's going to be vec2i, and where do we have a cursor position? Yeah, so there's an editor cursor row, editor cursor cursor row, right? So here is that. We might as well actually put it something like tile, right? So this one is going to be vec2i tile. This is a row, and this one is going to be the column, right? An interesting thing about this is that we have to cast it to integer and make it negative. Okay, so that makes sense. Let's recompile this entire stuff. All right, so something doesn't work because editor invalid type argument. Is it because it's not that? You think it's semicolon? It doesn't have it. Why am I reading chat? Okay, so editor. Yeah, because it's not a pointer. So we have I. Alright, so everything seems to be okay. Alright, I'm a little bit scared to actually test that, but we'll see how it goes. So this one is dead, src main.c, and it doesn't do anything because I didn't actually wire everything up. So where is another printf? Yeah, I need to remove that printf, and okay. So here, as I already said, I want to do glyph buffer clear, right, glyph buffer clear, then render cursor, right, we're rendering the cursor, and we are doing this thing one more time. There we go. That's right, because rendering the cursor is going to append one single glyph in there, and yeah, so that's basically what we have in here. To be fair, you have to sync it, right? So you have to do glyph buffer sync, right? So we can even try to do something like that, right? So then you perform a call, and here you're gonna do another one. All right, so let me try to recompile this entire thing. All right. Render, it's a GL render cursor. All right, so it's completely broken, by the way. That's cool. So it's a classic, by the way. Render cursor. It's a freaking classic. Column and a row. So should be fine now. Okay. So that means I have to do int on the row. Right. Is it gonna work now? Hopefully. Now it's working. Look at that. So this kind of shit was not possible before, but now it is possible. We have the shaders and shit, and everyone has already left the stream because they thought it's a boring shit that they don't understand. But anyway, I don't care. So what I wanted to do now is do some interesting shaders with the vertex, right? So again, we can just add a shaking, right? So this is going to be shaking. Vec2, cosine time, sine time, intensity is going to be like around 20, right? And we just add the shaking in here, and you would be able to have a shaking while editing the text, right? And it has to be actually, you know, sort of desynchronized. So plus style X plus style Y, right? So style X plus style Y, and hopefully that will be rather interesting. All right, so can you edit shit like that? You should be able to. So define foo test. It's kind of difficult to add this kind of shit, but it's usable, I would say. I think it's usable. So that's pretty cool. I feel these the same. Alright, but we're not gonna do that right now, so I'm gonna actually remove the shaking. And probably also remove, you know, the rainbow shit. Right, so yeah, that's pretty cool. So if we start fresh, right? So if you start fresh, this is how it's gonna look like for you. If we're gonna actually add the rainbow shit, right? I think it needs to be HSL, similar to the filter that we use for the Sodium Pride, right? Yeah, so we can use HSL animation thingy. Yeah. We can give it a try, I think. That's pretty pogue. That's pretty pogue. We can also maybe do zoom in and zoom out, if you know what I'm talking about, for the camera. So that would be also pretty cool, I think. Okay, so let me do a committee of what we've done so far. All right. Fully integrate OpenGL renderer with the editor, right? So there we go. With the editor. So what else didn't want to do? Yeah. So let me actually find the emote jam. Right, so for those who doesn't know, emote jam is the thingy that I made for animating emotes. If anyone is interested, you can find it in here. But one of the filters that it has is this one. So it just basically scrolls through HSL. I'm also going to put that in the description for people who's watching on YouTube if anyone's interested. Emote jam. So yeah. And this entire thing is completely open source. You can find the source code in here. So just in the corner, click on GitHub, and you can use it for free for anything you want. All right. So, and as far as I know, it has, yeah. So, is it, yeah, filters, Pride. And here is the thing that it uses, right? HSL to RGB, pretty convenient. I stole it from the internet, I don't remember where. Font frag is this one, right? Font frag. And instead of the rainbow in here, what we want to do is essentially, so this is going to be vector 3. Maybe it could be vector 4, to be fair. Vec 4. And so HSL to RGB, and HSL is going to be something like, I suppose time, and the rest of the thing is going to be like 0, 5. And then we just set 0. So let's give it a try. And well, yeah, it's pretty interesting. It's a little bit fast, I would say. Maybe we should actually slow it down like twice. So yep, looks good. Maybe we can make it even better by this thing. Might as well do that main C. So here's the source code, right? But again, we want to kind of offset this kind of stuff with the UV coordinate and position and so on and so forth. So I suppose we're gonna do UV X plus UV Y, right? Oh, this one is actually rather interesting. That's pretty cool. Maybe we can even do it like that, right? So if we multiply it like this, all right, that's not bad. I wonder if we can also use the rows and columns themselves, right? The rows and columns, like, yeah, because we know the actual position in there. So that means we'll have to use frag coordinates, right? Maybe that's precisely what I can use in here, just frag coordinates. GL frag coord X, and this one is going to be GL frag coord Y. So that's precisely what I can do in here. And okay, I see. It's just very, very fine. It's just very, very fine. Maybe because of that. Well, we can actually like use something like vec2 frag UV, right? And GL frag coordinate divided by resolution. Something like this, and it's gonna be a frag UV, so maybe that will make something interesting. And of course we don't have a resolution. I think we need to accept it from here. Vec2 resolution, so vector size mismatch 49. Yep. Okay, so maybe we can just make it like this, whatever. 40. Alright, so maybe we have to do that separately, sure. GL frag coord, Y resolution Y, resolution X. There we go, so that's what I wanted to have. Though I think you can just do something like XY divided. I think this is how the professional programmers do that. Yeah, I think that's the way to do that. Yes, that's what I wanted to achieve. You see, so it sort of like feels like a uniform thing. It's like scrolls HSL through the entire thing. Right, that's pretty important, right? It makes it feel like the whole uniform. That's cool. I like that. Right. It feels like we don't even need to simplify the shit in here. Right. It should be fine even like this. Oh my god, this is perfect. Yes, that's ship it. We're gonna fucking ship this shit. Yes, we're shipping this shit. Perfect. This is the gayest editor I've ever seen in my entire life. I love it. All right. Okay. Perfect. Freaking perfect. So. Now. So it would be kind of cool if all of that was also customizable. I think this can be considered a PhD project as well by Microsoft, probably. So add a rainbow to the fragment shader. I'm gonna push that right into the repo. Now, so we have a lot of things to do in here. Specifically, we need to remove everything related to SDL renderer because it became completely obsolete. So I can even commit like OpenGL renderer as a default. But I think I'm gonna do that off screen because there's nothing particularly interesting in like removing this kind of code. Right, so that's pretty cool. I like that. I really like that. So of course it's not really usable right now. Right, so all of that is just to demonstrate what you can do with these shaders and whatnot. But once we have this renderer, right, we can try to focus on making the experience more interesting, right? So we're gonna use this renderer for like creative expression and whatnot. But yeah, I really like how it like feels like the original renderer, but it's better, right? Because we have control over shaders and whatnot. So yeah, I suppose I'm gonna make a pull request. So OpenGL renderer. So I suppose finish the OpenGL renderer. The whole canvas should constantly rotate though. Probably. I don't know, we can also try to rotate individual characters. Could be interesting. Alrighty. So I also need to report a couple of issues in here. Snitch report. Append body introduced in 17, I suppose, right? So save file, no. Incursus, we should be able to integrate with Incursus, but I mean, we don't really care about Incursus anymore, to be fair, once we've got this kind of shit. So this is that. Blinking cursor could be also interesting. Delete a line. No, no, no. Mouse click. Okay, so mouse click is broken. Update the viewport. Okay, so this one is also needs to be reported. All right, so we reported 2 issues. I don't want to report all of them because some of them are like, you know, really experimental and I'm just going to work on them myself. Okay, so something is completely broken. I can clearly see that. Characters individually. Well, I mean, the code is open. You can just grab it and implement that yourself. I mean, it's under MIT license, sure. So I just want to fix this thing. Maybe we're gonna make the shaders customizable without the like restarting the editor. Could be actually rather interesting. I aren't smart enough for that. Well, the open source is basically you can either implement a feature yourself or you can find somebody who can implement the feature for you and pay them. So this is how open source works actually. So let me see. Build dead. Alright, so function conversion process due to possible loss of data. Oh yeah, okay, so it's probably because of the implicit conversion of this kind of shit. Okay, I see. So this is size. I need to explicitly say that I want to do it like that. Sure. Thank you, Microsoft. Very cool. 87. 187. And I suppose I have to do this kind of stuff explicitly for all of them. 194. Okay. 339. From size T to GL int. Oh shit, this one is rather interesting. Well, really? Why did it work before? How did it work before? Amount of components. Well, okay, so maybe the amount of components should be equal to the type should be what you would expect. So let me actually find that function. GL. So this is the function we have. So GL size is actually GL int. Glyph attribute definition. GL int. And for the offset, we explicitly converting it anyway, so should be fine. So let's take a look. All right, I really like it. It looks really cool. Okay. So what's the next problem? 349 as well. 349. I suppose it's the same shit. So in pride indeed. 462. 462. And nary minus operator applied to unsigned type, resulting in unsigned. Ah, I see what you mean. 473. And here, conversion GL size I. I suppose that's what it wants. Okay, let me take a look at the function, right? So it can be something like this. GL3, go. Okay, so I see. So GL size I, and in here 4773. 481. The same situation. Okay, I think I fixed everything. Hopefully. Okay, so I'm gonna try to fix the MSVC build. Try to fix MSVC build. In any case, I guess I'm gonna call it a day. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all next time. Next time we're gonna continue working on this editor, and we're gonna try to implement something finally interesting using the new technology that we invented in here. You know, PhD worthy technology. So check out the source code. You can find it in the chat or in the description. Leave any issues in the repo if you have any problems building it or running it or something like that. We can discuss it there. And I'm gonna go. Thanks everyone. Yeah, love you.